Experiment number 7. Find the distance and elevation of inaccessible object by double plane method. In last week, okay, in last class, we discussed about in last lab we discussed about how to find out the distance and elevation of inaccessible object by single plane method. In experiment number 6, we discussed about how to calculate the distance and elevation by using single plane method. Experiment we are going to discuss about find the distance and elevation of inaccessible object by double plane method. Okay, by double plane method. For example, okay, so this is the way, this is the actual picture, how to conduct the survey. Okay, so what is the aim of this experiment? Okay, why we need to do this experiment is for the oral. Okay, to find out the oral. What is called oral? Oral means reduced level. Okay, that means the height of a place which is calculated from the sea level. The height of a place which is calculated from the sea level is called the reduced level. Okay, so throughout the world, okay, all the land surfaces are having different oral values. Why? Because we are having features like mountains, valleys, so many land features are there. So each and every land features having distinct oral values. Okay, having distinct oral values. So in this experiment, we are going to find out the oral value of a top of an object when the base of object is inaccessible. Have you know what is accessible and what is inaccessible? Have you remember in last class I told you meanings between the difference between
Yes,
a
sir. Yes, sir.
accessible and inaccessible.
Possible, na,
Okay,
sir.
accessible means
Accessible means possible.
possible. Okay, accessible means nothing but
Yeah,
possible to do something is called
possible.
accessible. For example, if you want to
Definitely.
uh, okay, for example, who are all new to this class, please listen it carefully. Okay, what is the difference between accessible and inaccessible? Okay, so see here. So if it is a tree, okay, and you are standing here, and you notice that some of the fruit is falling here, some of the fruit is falling from the tree. Okay, now can you able to get this fruit? Yes, you just walk to near to the tree and you get these fruits, right? So it is called accessible. It is called accessible. If you same thing, okay, same thing, you just think, okay, if the land feature is like this, if the tree is on mountain, if the tree is on mountain, okay, the same thing, okay, now you can't able to reach as easily, right? Why? Because here the land surface is very straight, so you can easily walk to the tree and get the fruit. It is accessible. But here the land feature is not straight line. Okay, it has some ups and downs. So you some difficulty to reach the tree. So it is called inaccessible. Now you understand what is the meaning of accessible and inaccessible.
Repeat, sir, one time, sir.
Okay, accessible means possible, right? Here in
Oh,
this condition,
okay, sir,
you
understand.
can able
But
to
here, sir, yes, but here, sir, going to, sir, difficult, sir, tree to, but here, no difficult, sir.
yeah, okay,
So in
because of difficult
below,
rate of difficulty we set it as
inaccessible.
access. Okay, accessible and inaccessible, two things are there, accessible and
Okay.
inaccessible. So we are going to, in our experiment, in the seventh experiment, we are find the distance and elevation of inaccessible object, not accessible object. Okay, inaccessible object by double plane method. Okay, by double plane method. So what is a double plane method? So see here, there will be some uh, hill station. Okay, over the hill station some cell phone tower is there. Okay, some cell phone
Yes, sir,
tower.
yes.
Okay, I want to know the height of this tower. I want to know the height of this tower. How do you calculate the height of this tower? Okay, so here it is a mountain. Mountain having mountain. So in this condition, how do you measure the height? Okay, as well as how do you measure the distance, horizontal distance from your point, cell phone tower point? How do you find out the horizontal distance from your point? If you are standing here, you just imagine if you are standing here, okay, and you plan to calculate the horizontal distance as well as vertical height of the cell phone tower. How do you calculate? Okay, so by this double plan method, we are going to calculate the distance as well as height of the cell phone tower. Okay, distance as well as the height of a cell phone tower, double plane method. Okay, double plane method. Okay, so what are the things? Okay, so see here, for this, okay, we are going to use instrument called theodolite or tachometer. For this, we are going to use the instrument called theodolite or tachometer. Okay, so for that, in previous case, we are fixing instruments at two places. Instruments at the two places, but here you need to fix one instrument at different elevation level. At different elevation level. Okay, at different elevation level, you need to fix the instrument. Fix the instruments at different levels. Okay, for example, first I am fixing this instrument here, point A. Okay, I name the instrument station as point A, and I name this instrument station as O. Sorry, object station as O. Object station. This is object station, and this is instrument station A. Okay, I am going to
Yes.
fix one instrument. I am going one more instruments. Okay, which is far away from the instrument. Okay, so here the land. Okay, one more land range is there. Here I am going to fix one more instrument. Okay, this is this instrument. I name this instrument as B. I name this instrument as B.
B.
Okay, now I am going to take the measurements. Now I am going to take the measurements. So before that, we need to know the formula. What are the formulas actually we need to use for this? Okay, what are the formulas we need to use for this? Okay,
Yes.
okay, please wait. So these are all the formulas actually we need to use for this experiment. Okay, these are all the formulas we need to use for this experiment. This is visible.
Yes, sir.
Okay, so
Yes, sir.
okay, so here see, here they are giving a height, horizontal height, h1 value and h2 value. What is the formula of h1 and h2? Nothing but d into tan alpha 1. H1 is nothing but d into tan alpha. H2 is nothing but rq1 tan alpha. R1 tan. Okay. So here instead of A, I am taking it as P. Okay, P, and this is Q, and this is R for calculation purpose. Calculation purpose, I am taking this. Okay.
Okay, sir.
So first, okay, very first, what you do? Okay, in the station P, from the station P, you need to focus the, you need to measure a angle, vertical angle. You need to measure the vertical angle at the cell phone tower. Okay, at the top of this cell phone tower. So here we are getting one angle, right? Here we are getting one angle. Is it or not? Okay,
Yes,
that
sir. Yes.
is alpha 1. Okay, that angle is named as alpha 1. Okay, so this is the alpha 1. Okay, vertical angle. Vertical angle measured from vertical angle from what is the station name? Instrument station name. What is the instrument station name? Vertical angle from P. Okay, we measure the vertical angle from the P point. Next, okay, next what we do? Okay, so from P point, from this P point, we need to rotate the telescope towards R point. We need to rotate the telescope towards R point as horizontally, and measure the angle as theta 1. Okay, to here you need to measure a horizontal angle. You need to measure the horizontal angle called theta. Theta 1 is nothing but okay, a horizontal angle which is measured from P, which is measured from P. Okay, so theta 1 and alpha 1. Okay, theta 1 and alpha 1. Same thing. Okay, after that, after completing this process, okay, so from now from Q point, now from Q point, you need to locate the cell phone tower again. You need to locate the cell phone tower again. So here we are getting one more angle, vertical angle. Here we are getting one more vertical angle called alpha 2. Here we are getting one more angle called alpha 2. So alpha 2, what is alpha 2? Alpha 2 is nothing but vertical angle. Okay, vertical angle measured from okay, vertical angle measured from wow, who is coming again and again? Okay, vertical angle measured from which point? What is the instrument station? Name of the instrument station? What is the name of the instrument station?
Sir, theta 1.
Not PQR, instrument station, name of the instrument station. From our point, we are viewing the Q, right? So,
Red point
angle,
instrument, sir. Red point instrument, red point.
this is R, this is P, this is Q, and this is R. From the R point, we are queuing the Q point. We are locating the Q point. So, here we are getting one more vertical angle. Alpha 2 is nothing but vertical angle which is measured from point R. This is point P, and this is point R, and this is point Q. Okay.
Yeah, sir.
And again, okay, again from the R point, you need to visit the P point again. From the R point, you need to rotate the telescope towards point P and measure the horizontal angle and measure the horizontal angle. Okay, that horizontal angle is nothing but theta 2, and horizontal angle is nothing but theta 2. So theta 2 is nothing but okay, horizontal angle measured from point R. Okay, so alpha 1, theta 1, alpha 2, theta 2. So once if you measured all those things, you need to substitute this value. You need to substitute this value in formula for finding the H1 and H2. For finding the value of H1 and H2. Okay, so H is nothing but what is H1 is equal to D tan theta alpha 1. Okay, theta alpha 1 and H2 is equal to RQ1 into tan alpha. RQ1 tan alpha. Please wait. RQ1 dash. Hello. Hello.
Hello, sir.
Yeah, hello. Hello.
Yes, sir.
Yeah. So for that we need to find out the D value. How do you find out the D value? How do you find out the distance
Yes, sir.
value? Okay, so here we are calculating D1 here, D1 and D2. Two distances are there. Why? Because both the instruments are not having the same D value. Both the instruments are not having a same D value. So we need to find out the two distance value. How do you find out? Have you remember last formula?
Yes, sir.
The formula. Last class we discussed, in last lab we discussed some formulas for calculating the D. What is the formula of calculating the D?
D, sir,
HD
HD
minus B tan alpha 2
minus T tan alpha by tan alpha 2 minus tan alpha 1.
D is equal to distance D is equal to HD minus B tan alpha 2. Okay, so please wait. I will take this formula. Okay, I will take this formula once again. Please wait, please wait. So what is the formula for D? For calculation of D, what is the formula? D is equal to, okay,
Not
D is equal to H1, sorry. Okay, H2, sorry, H2 minus B tan alpha
B tan alpha by tan alpha
divided
2
by
minus
tan
tan alpha
alpha 2 minus tan alpha 1 minus tan alpha 1. So see here, we are having how much tan alpha 1 and alpha 2. We have measured alpha 1 and alpha 2. So here we are measuring two distances. If you see here, we are measuring two distances. Okay, so from instrument station P, okay, instrument station P to Q we are having one distance, and instrument station Q to R we are having one distance. So we need to find out two distances, DPQ and DQR. DPQ and
and DQR.
DQR. DPQ and DQR. So what is the formula? It gets changed, slightly gets changed. H2 minus B. Why? Because P point we are having alpha 1 only, right? So P tan alpha 1 divided by tan alpha 2 minus tan alpha 2 minus tan alpha 1. This is a distance of PQ. And distance of QR, how can you find out the distance of people? So S2 SP minus B tan alpha 2 divided by tan theta 2, so tan alpha 2 minus tan alpha 1. Okay, this is the formulas for finding the distance between a PQ and then how do you find out the distance? How do you find out the distance? So H is equal to D tan alpha 1. Okay, D tan alpha 1. So here we need to find out the average value. We need to find out the average value. Okay, first, okay, understand the formulas. I understand the formulas where D is nothing but D1. We are find out two distances, right? D1 plus D2 divided by 2 for taking average distance. Average distance, that D is nothing but the average distance of D1 plus D2, and alpha is also taken as alpha average, alpha 1 plus alpha 2 divided by 2. Okay, how you understand? Hello, have you understand?
Yes, sir.
Okay, so now we solve a problem. Okay, like in this condition we need to solve a problem. Okay, so I'm taking this problem. Can you able to read this problem? Instrument station
Yes,
A.
sir. Example 2.
Okay, vertical angle alpha 1 and vertical angle alpha 2. Two things are there. Okay, two things are there. So what is the formula? So HD is nothing but the difference between these two instrument stations. The difference between these two instrument stations. Instrument station height HP. Okay, instrument station height of instrument station P HP is equal to how much they are giving in question. In question, how much they are reading on benchmark 1.75 meter. Okay, 1.75 meter. Okay, so like that HQ, how much they are giving HQ? 2.10 meter. Sorry, HR, sorry. HR is given as 2.10 meter. Therefore, HD is equal to HP minus HR. Okay, HP minus HR. So you please replace in higher value into lower value. Okay, so 2.10 minus 1.75 meter. How much? How much the difference? 2.10 minus 5.
Sir, 1.25.
Yes, yes. One point 1.25. 0. The difference is, okay, this is 0.25 and 0.35. It's the difference. 2.10 minus 1.75. How much? How much, pa?
0.25, sir.
Okay, 0.35,
25.
right? 25. Okay, 0.2.10.
25.
Sorry, 2.10. This is 11. So 10. 0.35. The answer is 0.35. 2.10 minus 1.75. How much? Hello?
Yes, sir, right, sir. 0.35.
0.35.
Right,
So
right, sir.
0.35. SD value is 0.35. Okay. So first we need to find out the dpq, right? dpq. So dpq is equal to, what is hd value? Find out. 0.35. 0.35 minus, what is b value? B value is nothing but distance between a P2R. Distance between, okay, this distance between this P2R. Distance this P2R instruments. How much they are giving? 50 meter. Question they are giving. Okay, here P2 instead of PQ I am giving is as, okay, so PQ is given as 50 meter. PQ is given as 50 meter. 50 meter. Okay, 50 meter. So what is B value? What is the B value? Then B value is nothing 50 into tan alpha 1. What is the alpha 1 they are giving? Vertical angle. In question, what is the vertical angle they are giving? Alpha 1. What is the vertical angle they are giving, pa? For first P point, how much vertical angle is given? Hello?
15, 15, sir.
15 degree. Okay, 15 degree they are giving. So 15 divided by, what is tan alpha 2? Second, what is the second value they are giving? What is the second value? Vertical angle
11
they are
degree, sir.
11 degree. Okay, so tan 11, tan 11 minus tan 15. Tan 11 minus tan 15. So how much vertical
Minus
we need?
10.4.
Find out the tan 15 value. First we need to find out the tan 15 value. So 0.35, 0.35, sorry, minus tan 15. So 50 into, what is the value? 15. So what is the tan 0.279? Tan 15 value is 0.2679. 0.279. Okay, 0.2679.
Minus 10.4, sir.
Okay, divided by tan 11. What is tan 11? What is tan 11? So we need to find out the tan 11 also. So tan 11. How much tan 11? 0.1943. 0.1943. 0.1943 minus, okay,
10,
minus
15
tan 15.
value.
Again 0.26, 0.2679. So how much the distance is? How much the distance is? We need to calculate, right? So
Yes, sir.
0.35, sorry, 0.35 minus 50 into 0.2679. 0.79 divided by 0.1943 minus 0.2679. It gives you how, what is the distance, d value? What is the distance between PQ? Distance PQ value is
177.241.
17. DPQ value is 177.24 7.24 meter. The same thing, we need to find out one more distance. How many distance we are having? DPQ and DQR. Okay, DQR. So distance DQR is equal to, what is the formula? DQR formula. What is the formula, pa? Same 0.35 minus 50 into tan 11. Now it is tan 11. Okay, second value is 7. So tan 11 divided by tan 11 minus tan 15. Tan 11 minus tan 15. Okay. So what is the tan 11 value? You find out, already you find out the tan 11 value, right? So 0.35 minus wait. So minus 50 into what is tan 11 value? What is tan 11 value? We already find out here. What is tan 11 value?
1943.
0.1943 divided by again 0.1943
43 minus
minus 0.2679.
0.2679.
So now we need to find out the distance value. Now we need to find out the value. Please wait. Hello. Okay. So we have to calculate this. So for that 0.35 minus 50 into 0.1943, which gives you divided by 0.1943 minus 0.2679. See, so how much the distance QR is? What is the distance QR? DQR is how much? DQR is
127.241.
127.241.
127.2.
127.241 meter. 127.41 meter. Okay. Okay, so by this way we need to calculate the DPQ value and DQR value. Okay, so now we need to find out how to find out the V value. What is the formula of V value? What is the formula of V value? Height value. H is equal to D tan alpha 1. D tan alpha 1. Okay, this is the formula, right? Okay, so for this D, okay, for D, we need to add this two things, dpq plus dqr divided by 2. Okay, 177.24 plus 127.24 divided by 2. Okay, 177.24 divided by 177.24 plus 127.24 divided by 2. So already we know 127.24 plus 177, sorry. Okay, 177.24 plus 127.24 divided by 2, which gives you the average D value, Okay, what is the average D value here?
One 152.24.
52.24. 150.24. And what is alpha 1 value? Alpha 1 is nothing but 15 degree, right? Tan 15. So 124 tan 15. Sorry. What is the tan 15 value? 152.24. Already we calculated tan 15 value, right? Here we calculate tan 15 value. How much? 0.2679. 0.26. 0.26. Right. 0.2679. So now the height value. How to calculate the height value? Hello.
Hello, sir.
Yeah, I mean audible.
Yes, sir. 152.4 into
0.2679. 0.2679. 152.24 into 0.2679.
2.079.
Okay, so what is the height value? H value. What is the height of the tower? What is the height of the tower now?
40.78 G2.
40.78 meter.
G2.
40.8 meter. Where we need calculating the height of and distances. Okay, height of a tower and distances. Is it clear?
Yes, sir.
Clear? Hello.
Yes, sir.
Yeah. Is it clear? How to calculate the
Yes, sir.
distance of tower by means of double plane method? Have you understand?
Yes, sir. Understand.
Others, please respond.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Please wait. I need to take attendance. Please wait.